if you take it as a quadrant, clearly it is an acute angle which is less than 90 degree and greater than 0 degree. That is, x lies between 0 to pi by 2. Tan is sine by cos. When you divide it by sine, sine and sine get cancels. You are left with cos. So after applying this, we will get cos 0 divided by pi minus 0. Cos 0 is 1, pi minus 0 is pi. The value is 1 by pi. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidyashram, the Temple of Excellence, Mysuru. So in today's session, we will be learning about the limits of trigonometric functions. So in our previous session, we have learned how to find the limit of functions which are in a form of polynomial or rational function. Now we are going to find the limits of a trigonometric function. So let's see how to find the limits of a trigonometric function. We have a theorem here. So the theorem says, let f and g be two real valued functions which are in the same domain such that f of x is less than or equal to g of x for all the real values of x. Then they are in the same domain. Then when you apply the limit for those functions and if it exists, that is limit of f of x and limit of g of x exist, then it says limit of f of x is always less than or equal to the limit of g of x in the same domain as x tends to a. So whenever we have two functions in this form, f of x is less than or equal to g of x and limit of f of x and limit of g of x exist in the same domain, then the limit f of x is less than or equal to limit g of x. Next, we have one more theorem. It is also called as sandwich theorem. Here we are taking three different functions on the same domain. Let f, g, h are real functions on the same domain such that f of x is less than or equal to g of x, less than or equal to h of x for all x in the domain, in the common domain. Then again, the limit of the function exists, that is limit f of x, limit g of x and limit h of x exist. And the condition is here if limit f of x and limit h of x value is L. If the limit f of x value and the limit h of x value is also L, then limit g of x is also equal to L. That is, when g of x is a function in between two functions f of x and h of x, and f of x and h of x has the limit value L, then g of x also takes the value of limit L. So here I can explain through a diagram. So let this be an f of x and this is g of x and this is one more function h of x. So you can see, so at some point x is equal to a, the function f of x has the limit point L, even h of x has the limit point L. So therefore, h of x also has the limit L. Since g of x is sandwiched between f of x and h of x, you can say it is called a sandwich theorem. This sandwich theorem has a unique application in one of the theorem which we are learning now. So here we have a theorem, prove geometrically that limits x tends to 0, sin x by x is equal to 1, where x is measured in terms of radian. Very important question for your examination for 5 marks questions. Very important 5 marks question, compulsory question. Every time it is repeated. So very simple proof with the help of geometrical diagram. So let's start now. So before proving this result, limit x tends to 0, sin x by x is equal to 1, I should make some constructions here. So also I'll write whatever construction I'm doing in the theory part. So here consider a unit circle. So let us start writing the explanation. Consider a unit circle. Next is angle AOB is equal to x. Let angle AOB is equal to x and x lies in between pi by 2 to 0. Clearly from the figure, if you take it as a quadrant, clearly it is an acute angle which is less than 90 degree and greater than 0 degree. That is, x lies between 0 to pi by 2. Next is, draw BD and AC perpendicular to the radius OA. You can observe here OA is a radius, OB is also radius. So what I am doing here, I am drawing BD and AC perpendicular to OA. Draw BD perpendicular to OA and AC perpendicular to OA. So after drawing this, let us join this line AB, and OB is till here. So let me extend to meet the point C. So join AB and extend OB to meet C. So this completes my construction part. So whatever you are doing here, just write it here. Consider a unit circle. Let angle AOB is equal to angle X. Draw BD perpendicular to OA, AC perpendicular to OA. You can take it as CA also, which is one and the same. Next, join AB, extend OB to C to meet it. So this is what my construction. So next, from the figure, you can observe here, you have a triangle AOB. That is triangle AOB. AOB is also a sector. AOB. And along with this, you have one more right angle triangle, a very big right angle triangle, which is OAC. So from the figure, we can observe this. Area of this triangle is less than the area of this sector, and this area is less than the area of the triangle, bigger triangle AOC. So whatever you have observed, just write down. From figure, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. So now apply the formulas to find the area of a triangle and area of a sector. What is area of a triangle? Half into base into height. Let us consider only this triangle. So I have BD here. So now area of this triangle is half into base into height. So it becomes half into OA into BD. BD is the perpendicular distance or the height of the triangles. Next, area of a sector is always angle divided by 360 into pi r square. But here 360 cannot be taken in the degree form since x is measured in terms of radian. I'll take 360 degree as 2 pi. So x by 2 pi into pi r square. So your r is, radius is OA. So it is OA square less than. Now area of this triangle. So it is a right angle triangle. So half into base into height. So that is half into base into height. Now from here you can see pi get cancels. Also half OA is repeated in each term. So we can remove half OA since it is positive quantity. After removing half OA, what we are left with? BD less than x into OA less than AC. So this consider as equation 1. So from the diagram you observe this area of a triangle AOB less than area of sector AOB, which is less than the area of triangle AOC. Apply the formula half into base into height, x by 2 pi into pi r square. Your radius is OA, so it becomes OA square, and half OA is a positive quantity which you can take out. So you are left with the given equation. Consider this as equation 1. Now I'll find the value of BD and AC and substitute in the equation 1. Now let us consider this small triangle, this OBD. So in triangle OBD, what is sin x? Calculate sin x. Sin x is opposite side by hypotenuse. So this becomes BD divided by OB. So this is opposite hypotenuse. Now this OB can also be written as OA. Why? Because those two are the radius of the same circle. So I can replace OB by OA. Now what I need? I need only BD. So therefore BD is equal to OA into sin x. Now let us consider the big right angle triangle, that is AOC. In triangle AOC, tan x is opposite side by adjacent side. So that is AC by OA. So therefore I need AC. AC is equal to OA into tan x. So now I got the value of BD and value of AC. Substitute in equation 1 here. So let us write this equation in this form. We have BD less than x into OA less than AC. Now what is BD? OA into sin x. So this less than x into OA less than OA into tan x. So this is from equation 1, or equation 1 implies, after substituting we will get this equation. Again here OA is a positive quantity which is common in all the terms. So remove it out. So we are left with sin x less than tan x. Next step is divide throughout by sin x. So divide throughout by sin x. So what happens when you divide throughout sin x? This equation implies 1 less than x by sin x less than tan is sin by cos. When you divide it by sin, sin and sin get cancels. You are left with cos x. So after this, taking reciprocals. Because in the question you need it in the form of sin x by x. So take the reciprocal. So after taking reciprocal, you will get the equation as cos x less than sin x by x less than 1. Because when you take the reciprocal, the inequality changes. So therefore, cos x less than sin x by x less than 1. So next, we will apply the limit as x tends to 0. So apply limit as x tends to 0 to the given equation. So what is my equation? Cos x less than sin x by x less than 1. So apply the limit now. So limit x tends to 0 cos x less than limit x tends to 0 sin x by x less than limit x tends to 0 1. Now when you apply the limit x tends to 0 for cos x, what will you get? So limit x tends to 0 cos x, apply the limit here. So cos 0 which is equal to 1. And when you apply the limit for a constant value, it remains same. So therefore, since limit of cos x is 1 now, we will get 1 less than limit x tends to 0 sin x by x less than 1. Because limit of a constant is itself. Now, you can compare this with the sandwich theorem. What the sandwich theorem says? If f of x less than or equal to g of x less than or equal to h of x, okay, and limit f of x and limit x tends to 0 f of x is equal to L, which is also equal to limit x tends to 0 f of x h of x. So if f of x is also equal to L and h of x is also equal to L, what a sandwich theorem says? G of x is also equal to L. So you can consider this as f of x, g of x, h of x. Now f of x value is 1, h of x value is also 1. So what is the value of g of x? It is 1 again. So by sandwich theorem, what we can conclude? By sandwich theorem, limit x tends to 0 sin x by x is equal to 1. Hence, this is the proof. So again, a very important question for your examination purpose, that is prove geometrically limit x tends to 0 sin x by x is equal to 1, where x is measured in terms of radian. So you have to write this diagram and this in the theory part, that is consider a unit circle, then let angle AOB is equal to x, angle lies between 0 to pi by 2, Draw BD perpendicular to OA, draw AC perpendicular to OA, join AB, extend OB to meet C. Whatever you're doing here, just write it here. Next is, from the figure, we are observing area of this triangle less than area of sector less than area of this triangle. Apply the formula you are getting with equation 1 after taking half OA, which is a positive quantity, outside the relation. Next, calculate the value for BD and AC here. So, using triangle OBD, you will get BD is equal to O sin X, AOC OA tan X. Again, apply it in equation 1. Take OA outside, you are left with the equation sin X less than tan X. Divide throughout by sin X, you are left with this equation. Taking reciprocals, inequality changes. So, cos X first, sin X by X next, 1 next. Apply the limit as X tends to 0. Applying the limit, you will get in the form of a sandwich theorem. By using sandwich theorem, we can conclude limit X tends to 0, sin X by X is equal to 1. Now, we have learned the theorem. Let us see the application of this theorem in solving the limits of trigonometric functions. The very first question is, limit X tends to 0, sin AX by BX. Now, according to the theorem, it should take this form. So, sin X by X form. Suppose it is sin theta, then it should be sin theta by theta. If it is sin root X, then it should be root X in the denominator. So, whatever the value of X is here, it should be same as here. So, only then if you apply the limit as X tends to 0, it will be equal to 1. So, making using of this concept, we will solve certain problems in trigonometric functions now. So, here it is in the form of AX. I need AX in the denominator. Already we have X in the denominator. So, multiply A, divide by A. So, limit X tends to 0, sin AX divided by BX. Multiply A divided by A here. So, take A constant, B constant outside. So, it becomes A by B. Limit X tends to 0, sin AX by AX. Now, this is in the form of sin X by X, whose value is equal to 1. So, the whole equation will become 1. So, the answer is A by B. Next question. Limit X tends to 0, cos X by pi minus X. Directly apply the value of X is equal to 0. So, after applying this, we will get cos 0 divided by pi minus 0. Cos 0 is 1. Pi minus 0 is pi, the value is 1 by pi. Next question, limit X tends to 0, cos 2x minus 1, cos x minus 1. Here I will use the trigonometric identity, that is cos 2x is equal to 1 minus 2 sin square x. So, if you shift 1 here, it becomes cos 2x minus 1, which is minus 2 sin square x. So, this is multiple angle formula. The same application can be done for cos x minus 1 using half angle formula. So, in the place of 2x, just replace with x. Then x becomes x by 2. So, apply the result here. So, limit x tends to 0. In the place of cos 2x minus 1, I am replacing minus 2 sin square x. And here I need minus 2 sin square x by 2. Minus 2 get cancelled. Now my question is, it should be in the form of sin x by x. But here we have sin square x. So in the denominator also I should get x square. And here it should be in the form of x square by 2. So for the numerator I will multiply x square and divide by x square. For the denominator I will multiply x square by 2 and divide by x square by 2. So therefore limit x tends to 0. Here sin x by x whole square it becomes into x square. So this is sin square x and I have divided by x square, so we can use whole square. And similarly here sin x by 2 by x by 2 whole square I can take and multiply by x square by 2 square is 4. Because it is x by 2 whole square which becomes x square by 4. Now this is square. But my question is only to apply the limit as sin x by x. Sin x by x square can be taken as sin x by x into sin x by x. So apply the limit twice, you will get 1 into 1. So therefore, when you apply the limit for this separately, for one time the value is 1. For the second time also the value is 1. Next here x square get cancelled. Again here sin x by 2 one times, the value is 1. Sin x by 2 second time, the value is 1. That is, we are left with 1 by 4 which goes to the numerator 4. So my answer for this limit is 4. Next question, 1 minus cos x divided by x. So here 1 minus cos x, again I'll use the same concept. So 1 minus cos x can be written as 2 sin square x by 2. So I'll just substitute here, limit x tends to 0, 2 sin square x by 2 divided by x. I'll shift this 2 here, so it becomes limit x tends to 0, sin square x by 2 by x by 2. So here I have square, but here I have only x by 2. So I'll split this, limit x tends to 0, sin x by 2 by x by 2 into sin x by 2. Now this is in the form of sin x by x. Apply the limit separately for these two functions. For this, the value will become 1. Again, if you apply the limit for this, it becomes sin 0 by 2. Sin 0 by 2, which is 0, again sin 0 is 0. So the value is 1 into 0, which is equal to 0. Next question, ax plus x cos x divided by b sin x. So here first I'll divide the numerator and denominator by x. So limit x tends to 0, ax plus x cos x divided by x plus b sin x divided by x. After dividing this completely, I'll get limit x tends to 0, a plus cos x by x whole divided by b sin x by x. Now apply the limits separately here. So when you apply the limit x tends to 0 for the value a, it is constant, so it is a. Again, when you apply the limit as x tends to 0 here, it becomes, so this value is equal to limit x tends to 0, a plus cos x divided by b sin x by x. Now apply the limit separately for all this. So if you apply the limit as x tends to 0 for the constant value, it is same. So it is a. And if you put x is equal to 0 here, it is cos 0. And here it is b into, so apply the limit as x tends to 0, sin x by x. So let this take the form of this. Now the value of this is equal to 1 and cos 0 is also 1. So the answer is a plus 1 by b. Because this expression is 1, so b into 1 is b in the denominator. Next question, we have 1 minus cos x divided by sin square x. Again apply the same concept of half angle formula. So therefore it is limit x tends to 0 to sin square x by 2 divided by sin square x. So let me take 2 outside. I'll get limit x tends to 0. I have here sin square x by 2. So I'll multiply x by 2 whole square, divide by x by 2 whole square. So therefore I can take it as sin x by 2 whole square into x square by 4, which is x by 2 whole square. Again in the denominator, here it is sin square x. So I'll multiply x square, divide by x square. So that sin x by x whole square into x square. Now you can see x square get cancels here. Apply the limit separately. For the numerator, the value is 1 into 1 by 4 whole divided by, again for this the value is 1. 2 1s are, 2 2s are. So after evaluating, the limit of the function is half. So yes, this is how we will solve or we will apply the limit for a trigonometric function based on the geometrical proof, that is limit x tends to 0, sin x by x is equal to 1. So if it is not applicable, directly apply the value of x to the given trigonometric function and find the limit value. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.